Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over some Unit 3 concepts on electrical sources. The primary methods to produce electricity are magnetic, or more specifically electromagnetic, chemical via a battery, pressure, which we call the piezoelectric effect. In a piece of quartz, if you apply force to the piece of quartz, we will generate a voltage. Solar or solar PV, and PV stands for solar photovoltaic, or thermal through the use of what's called a thermocouple. Now, the most prevalent method for generating electricity is electromagnetic induction. Two principles to keep in mind with electromagnetic induction: whenever you pass current through a conductor, whether it's AC or whether it's an AC or DC electrical system, whenever you pass current through a conductor, you generate magnetic flux, or basically magnetism about the conductor. Well, if we take that, for example, straight piece of copper wire, copper conductor, coil it up, we now concentrate that force of magnetism. So first principle, anytime there's current through a conductor, we generate magnetic flux about the conductor. Second principle, whenever you pretend my dry erase marker is a conductor, conductor has to be in motion. Whenever you move a conductor in a magnetic field, we induce a voltage in that conductor, which sets up current flow. And that's the primary operating mechanism behind, for example, how a squirrel cage induction motor would work, or how either a single or three-phase transformer would work. For batteries, we had seen this last week. The symbol for a battery, it has positive and minus polarity. And some important considerations to keep in mind with a battery: when a battery or batteries are connected in series, current remains the same, but the voltage adds. When a battery or batteries are connected in parallel, the current adds, and now the voltage is going to remain the same. Final topic to think about in Unit 3, the concept of static electricity. Static electricity, the idea that electrons are not in motion yet to contribute to current flow. So how we normally look at this, we call it Coulomb's law, or the law of electrostatic attraction. Like charges repel, unlike charges attract. So some practical considerations for static electricity: one would be the concept of rubbing a balloon on my hair, and then the balloon would attach to the suspended ceiling in my conference room here. How that works: the process of friction of rubbing a balloon on my hair, I impart what's called an excess of charge to the balloon. The balloon sticks to the ceiling has a deficiency of charge, the balloon is attached to the ceiling. Second concept of static electricity is the concept of lightning. The most prominent form of a lightning strike is cloud to earth. Again, keeping in mind this concept of excess and deficiency of charge. Cloud has an excess of charge, the earth has a deficiency of charge. The strike occurs from cloud to earth. Two other forms of lightning strikes, even though not as common, one would be reversing our thinking, earth to cloud, and the other would be cloud to cloud. So pretend for a moment, if the earth now has an excess of charge and a cloud has a deficiency of charge, the lightning strike would traverse from earth to cloud. Likewise, pretend I have two clouds, cloud A and cloud B. Cloud A has an excess of charge, cloud B has a deficiency of charge. The lightning strike would occur from cloud A to cloud B. And the last practical example of static electricity: walking on a carpeted floor in an office environment, for example. Again, the process of friction, the rubber or neoprene soles on my shoes. I impart an excess of charge to my person. When I go to reach for a metallic doorknob, for example, the doorknob has a deficiency of charge, so I actually transfer charge from my person, which has an excess, to the metallic doorknob, which has a deficiency. And I will also mention, depending on, let's say, how highly charged our bodies become, you may even notice what appears to be a little miniature lightning bolt. We call that corona discharge. The air gap that separates my hand that has an excess of charge and the metallic doorknob that has a deficiency of charge. We ionize the air and we transfer energy through the air. Again, we call that corona discharge, so it appears like a little small lightning bolt. All right, so please review the PowerPoint for Unit 3 as well as reading the text. Have a very good week, and we will see everyone next week. Thank you.